All right, so here is the full review about these quadratics. So in your quadratics, when you're graphing, come back up to here, right? So remember the A is the first number, the B is the second number, and the C is the last number. So A is 2, B is 4, C is -1. When you plug these in, what you're going to do basically is plug this into the axis of symmetry formula, which is right here. Right, so this x equals -b over 2a, that's your axis of symmetry. And when you plug the numbers in, the a, b, and c, we're going to find the middle of your table. So you're going to try and find this number. And that number comes from the b, right, is 4, so the opposite is -4. 2 times a, which is 2 times 2. -4 over +4 is -1. That's how we get that -1 there. All right, so that's the first part. Next, after that, you're going to want to try and find out how to get the other numbers here. And I'll show you this. So if you take -1 and you plug it back into this problem, you're going to find out the other portion of your vertex, which is that -3. So just to show you this -1, if I did -1 here squared, you do the power first, is 1, but 2 times 1 is 2. All right, now let me change my colors here. So that's a 2. Times another -1 here, so 4 times -1 is -4, all right? And then -1. So 2 minus 4 is -2, -1 is that -3. That's where this comes from. All right, so that's where you start. That's to find your vertex. Then go 2 numbers up, 2 numbers down. And when I look at these numbers around this -1, the 0 is much easier to do. So what I'll do is I'll just plug that back in. So if I put my 0 in here into these x's, right, 0 cancels all that out, 0 cancels this out, and gives you -1. So 0 minus 1 is there. So the nice part about parabolas, since we have this shape, they repeat on each side of that vertex. So since this is -1, -2 also is -1. Right, same thing with the other ones. 1, if I were to pick 1 and -3, 1's easier, and they will mirror each other. So if I put 1 in, right, 1 squared is 1 times 2 is 2, plus 4 times 1, which is going to give you 4. Right, so that's your 6, but then -1 gives me that 5. So that's where the 5 comes from, and you mirror on either side. Then you can literally plot these points, vertex. These are either the other points, that's the -2, -1. This one's the 0, -1. And 1, 5's here. -3, 5 is there, and you can make your parabola. Right, so that's by hand with a nice table and making a sketch of that. Now, one nice thing you can do is, I told you guys about this at some point too, Desmos is a great program, which I'll show you right here. If you go onto desmos.com, you can graph anything, it's free, and you can check your answers. So if I start graphing and literally plug in any problem, by the way, to get a power above the x here, I'm going to hit the caret, which is the symbol over your 6 on the keyboard. So if you hit Shift and 6, it goes up. And then you have to arrow over and put in whatever your equation is. And then there's your equation. It's nice you can actually drag around too and find different pieces. But that'll help you technologically check your answers to make sure you're right if you don't have a graphing calculator. All right, so going back, by hand or by Desmos should really help you. So here's the factoring, and I picked out 3 different types because you'll see these most commonly. So first type is difference of squares. Difference of squares, there's a square here and a square there. Remember, you have to take the square root, that's really the square. So if I do the square root, which is x, the square root, which is 3, do 1 with a plus, 1 with a minus, that's the difference of squares pattern. Done. Okay, so nice and easy. And then that's 2 terms, so that's how I can tell real quick visually that that's difference of squares. For this, you've got 3 terms, and this one you've got 3 terms, but notice the difference is there's no number in front. Well, there's really a 1, but no number in front visually. And there's a 2 in front here, so 2 different types. So this is what we call the original factoring, or the easy factoring. But since there's no number in front, find the numbers that are going to multiply to give you -14. which could be 1 and negative 14. Could also be 2 and negative 7. But remember, you could also have negative 1 and 14. Right? You could have the opposites here. Or you could have negative 2 and you could have positive 7. So which ones are going to multiply to give you negative 14 but add to give you 5? And look, this pair right here is going to add to give you 5. So that's why we put negative 2 inside and 7 inside. So that's your original factoring. Right. For this one, we call this the M method, for the little m it makes, or the AC method it's called, either way. But in this, multiply your n numbers of 2 times negative 9, so you get negative 18. Find out factors of negative 18. Well, there's more than these, but here, the more obvious ones. 6 and negative 3 gives me a positive 3, so not close. Well, close, but not correct. And negative 6 and 3 add to give me negative 3. So these are the pairs that we want, the factor pairs, that add to give me that middle number. So multiply the end, right, you get negative 18. What factors of negative 18 will add to give you negative 3? And here they are. So I drop those down and drop the end ones down. And we group the first two and group the last two. So look for a GCF in the front two, which is 2x. When you factor it out, you're left with an x minus 3. Now remember, these parentheses must always match, so I write that right again. And then look for a GCF here, which is 3, and check by distributing to make sure that they work, which that's 3x, that's minus 9. So once you get to there, you take your 2x plus 3, put that in the first parenthesis, right? Whatever's in front, they go together. And then the other two, which are exactly the same, combine to be that last one. And that's the factoring. All right, so those are 3 different ways to factor quadratics. Okay, so the last 2 here, that quadratic formula and completing the square, which is vertex form. So quadratic first, here's your formula. So the A, B, and C from before, again, they're in the same pattern. Plug them in. So negative 6 is B, so negative 6 is positive 6. Right, b squared, so negative 6 squared is 36, minus 4, a is 2, c is negative 4, and 2a on the bottom is 2 times 2. So plug in all those a, b, and c values. Simplify what's underneath this radical, which is the important part. So 36 plus 32. One little trick I use to get that symbol, make sure that's correct. A negative times a positive times a negative, right? 2 negatives makes a positive. So double check that. Use your calculator if you need as well. Right, the 6 comes along. The 4 on the bottom is 2 times 2 for the 4. And then we reduce this radical. Right, combine it to get 68. And if you remember, though, radicals, you want to see if these are completely reduced. So radical 68, if I bring it over here, do the tree thing, I see a pair of 2's and a leftover 17, so it's really 2 radical 17. Right, so here it is. So 6 comes down, 2 radical 17, and the 4 on the bottom. But I highlighted these 3 numbers in front, so look for a greatest common factor in just those 3, always to make sure it's reduced completely. This radical 17 is not involved, we did that already, but look for the 3 numbers in front, and they can all be divided by 2. So the 6 becomes a 3. The 2 is really a 1, but we don't put that in there. And the 4 becomes a 2. So this is really your answer there. So in exact form, it's 3 plus or minus radical 17 over 2. And if you did need a decimal answer, plug this into your calculator. Remember, do 3 plus radical 17, hit enter, divide by 2, you'll get a decimal. Then do 3 minus radical 17, get that decimal, then divide by 2. All right, so this is exact, but get decimals if you need. All right, and the last part over here, this is solving by completing the square, which is vertex form. Once you get this form, it is vertex. And hang on, I've got to make some space here. Get rid of all this. So we'll go through completing the square and show you how that all works. All right, so now we've got some room here. So what I did first was move the 2 over, so subtract 2. So here it is on the right. It's moved over. I create these boxes. This is where our square numbers are going to come from. Right? These boxes are on both sides. And how I find that number is take your b term, divide it by 2, so you get a 3, and you square it. So 3 squared is 9. You get the 9 there. All right, so going forward, this number is crucial because now this, nope, I don't want to do that, becomes, come on, arrow. If I bring it up here, this becomes x, and use what's in here. That's a positive 3, so this is plus 3 squared. I can write this in parentheses. Equals 7. So, and this is what's considered vertex form. So here's your solving in vertex form. Right, so because it's squared, I can do the radical on both sides. So that cancels your square. So this is x plus 3. And the 7 on the right side will not reduce. So it stays as radical 7, but it does become plus or minus radical 7. Okay, so that's there. And we're almost done. I need x by itself, so subtract 3. Once I subtract 3 on the right side, remember that just goes and sits in front of that plus or minus. So this becomes x equals, and it becomes 3, should be negative 3, plus or minus, then radical 7. Okay, so if you get that number, the 7 does not reduce, you get the plus or minus, and that number that comes over just sits in front. So that's really your exact answer. If you do need, well, I'll split it right here. If you do need a decimal, I would just split it up. Do negative 3 plus radical 7 and get your decimal for that. And on the other side, you would need to, come on, do negative 3 minus 7, minus radical 7. So really, if it's split up, you could do those two answers, or if you need decimals, you can actually do decimals for those two. All right, so that's a full review of everything, right? Graphing, factoring, quadratic formula, and completing the square, which is vertex form. All right, I hope that helps. Thanks.